Okay, here's a continuation of the four-bar mechanism analysis. So far, we've created this example here where we found it for one position, but it's going to be a lot more useful to us to find this for full rotation. So, and to create coupler curves out of this technique. So I'm going to adapt this spreadsheet for that purpose. In order to do that, I'm going to move some things around to make some room for myself. So I'm moving this graph over to the side and moving these plot points over here. Okay. And so what I'll do, I haven't saved in my queue right here in my copy. I have, I think it's going to show up. No, it's not. Okay, so, where'd you go? I want this guy right here. I want this graph so I can show you what the conventions are. Okay, so I'm going to save that for later. So here's what we're going to do to adapt this for our needs. I'm going to make a whole bunch of different angles here for theta 2. So I'm going to start with 0 degrees and turn these into radians. I guess I can just copy this over here, turn that into radians. Make this a little bit bigger so you can see it. And just so you know what we're doing, we can make them by increments. I'm going to start out with increments of 5. We can do that. We could change them later on. I'll drag this down here. Well, we don't need to go that far. Let's only go for 360 degrees for now. So that ends up being down to right around cell 90 if you're having to be trying to drag it yourself. Okay, so all of my K's, these are all constant, but the A, B, C, and D do vary. So I'm going to make headings like this. And I am going to very carefully go through here and copy. I'll do it all at once here. I'll copy down to there. Copy this one and put it into here, just in that top row. Copy this one. And keep going here for D. You know the routine. And we'll modify these here in a second. And last one here. Okay. I guess I could bring this row down right there. Okay. So what we want to do is we want to make it every time where we see this cell, we want to bring it over to this cell over here. So right over there and right over here. And then back up here, everywhere that it's not that cell, we want to hit the F4 button. So that's going to put $ next to all of those features right there. All right, so we don't want $ next to anything that's inside a cosine or a sine. Same thing here. Okay, all we need to do is move this cell down to there. And right up to here. Move this cell over to there. And hit an F4. And F4 there. And then F4 there. And this too. Like that. Okay. And an F4 here, F4 here, and F4 there. Okay. Oh, I went too far. Bring that back up. This right here, let's see. Move him down to there, and then everywhere There's an F4. Here's an F4. Everywhere an F4. Okay, let me just change this one briefly to 40 to make sure that I did everything correctly. Looks like I made a mistake. Nope, wait. Okay, yeah, that should match that. That matches. Okay, looks like I matched everything up. I'll bring that back to 0. All right. Now, I don't necessarily need to do both of the configurations. I'm going to leave them in place. I'm only going to use, because we found out last time that it's really the theta 3.2 and the theta 4.2 that are actually the open position instead of the crossed position, and we want to use those. So I'm going to come back over here, and I'm going to grab this and put it right here. All right, and so let me go ahead and write that that's theta 3, and I'll copy this, make it theta 4, and do the same thing over here for this theta 4. We have quite a few things we have to move now. I don't know if it's going to be worth our while. Yeah, okay, we'll just be very careful about it. All right, so theta 3 and theta 4. Okay, so theta 3, we want to move this guy, D, over to D, move all the D's over, move all the E's over, and then move the lone F over. This guy, we'll do the same thing for the A's. And the B's. And let's see. All right, and let's just double check that we got we didn't make a mistake when dragging a thing over. Make it 40 degrees again. And that should be matching up for the 0.3, yep. And that should be matching up for the 1.00. Okay, so we got it. That's good news. We can go ahead and for this, we could copy them all down if we wanted to. That's fine. This right here will be an interesting plot to make. So let's plot, all right, for a full rotation. Let's plot the movement of A. So we'll go X, A, and Y, A. We're also going to plot X, B, and Y, B, so we could label those right away. And so what that's going to look like, it's going to be equal to A here. Did I ever change that to, yeah, I forgot to change that back. Yeah. Okay. So I'm going to equals A, F4, remember, times the cosine of theta 2. And of course, it's going to be equal. This right here is going to be equal to this F4, remember, times the sine of theta 2. Boom. And here we're going to equal to, okay, so here's an important thing. We're going to equal to this guy plus the cosine of theta 3. And here we're going to equal to the YA plus the sine. Whoop, I made a mistake. Sorry, my bad, my bad. Back up to here. I forgot to put in. So let me just erase it. Okay, go back. Right here, we're going to have this plus B times, oh, and B needs to be F4. F4 times the cosine of this theta 3. Better. And then similarly, YA plus B times the, once again, F4, come on, times the sine of this. Okay. And we can double click all those down. Now, do I want to do this yet? I guess I will. I guess I'll show this to you. You know, I'm going to wait a little bit. Let's wait a little bit. Okay. All right. I want to do a coupler curve. So I'm going to introduce to you the conventions here for the coupler curve. So here is from a figure out of the book. We describe another parameter as AP. Okay, that's going to be the distance from this point A to the coupler point P. And that's a input, and it's in millimeters. And we need to come up with a number. We don't have really a problem where we have this same configuration here, but I think I'm going to make it something greater than the length of here, or than 1/2. So I'll make it 75 millimeters. And then I also, they're showing a del here. I don't think they're always consistent with using that symbol. I think sometimes they use a beta. But we'll go ahead and put in use that baby delta here, and put that in here. So something interesting. Let's make it 45 degrees. Why not? Okay, and that right there is. So what we want to do to be able to plot these points, we're going to take XP and YP. And in order to do that, we're going to build off of point A right here. So we go equals XA plus, and now we're going to take this AP, F4, times the cosine. Now we have to add things in. Okay, so we're going to take this plus the del angle, but we have to remember F4 right there. Boom. And we'll do the same thing here. We'll go the position of Y plus this thing, F4, times the sine of theta 3, 2 plus this angle right here, and then F4 of that, so it'll always call into there. And I don't know for sure that I got these right, but we'll see what happens. And I'll put my little things around here. So I want to plot three things. So, okay. I know why I did this. I changed the way that I was approaching this just specifically for here. I'm going to plot it directly onto this thing over here. All right, so I actually probably don't need my crossed configuration anymore. Maybe later I want to name these things. Maybe I will label the series. That's a good idea. Okay, so my first series is going to be, just call this A up here, B, and then P right here. Okay, so let me enter in, and I'm going to add to the series, add, and my label, my first one is going to be A. And then I will go all the way down here. I'll just go X. It's probably an easy way to do this, but I'm doing it this way. And then I'll go to Y for A. And then we will add in B. You can notice what was already on there. We're going to change the plot type there to get rid of those stupid markers. Can't stand it when people use markers for a string like this. Just change it to a line. So we're going to B right here. And by superimposing these, it's going to help us to make sure that we got the thing right. Oh, we're going to add in a couple other things too pretty soon here. Let me see. Okay, and then lastly, I want to add in my P. So I'll go point P, and X is on the P. All right, so right here, there's the coupler curve for the thing. Let me fix some of these things up here that I don't quite like. I don't like the way that looks, so we'll change this and get rid of the markers. So marker options, none. Right there, same thing on this, marker options, none, and marker options, none. And some of the things here, let's see. Okay, wait a minute. That didn't work for me. Marker options, marker options, none. Okay, good. I don't like that gray. I'll make this purple. All right, so that's definitely the line of the thing, but we don't have anything to show the coupler right here. So let me add in. Okay, we did that up here, didn't we? The plot coordinates. So we'll use something down here. I think I'm going to go for B and then P. Nope. Let me do this again. I'm going to go A, P, and B. And okay, so I'm going to plot those points again. So A, that just equals right here. So that's all these guys are going to be totally valid right there. And then, whoop, I should have moved that down. Whoops. I want P is going to be equal to P, and that's this one configuration, right? So that's going to be A plus, actually I don't have to do this. This is the crossed one, but I'll do it anyway. A plus, it's going to be that dimension times the cosine, the cosine of B, right? This guy right up here, thank you. That plus, this is completely unnecessary to do this one, plus this. I believe so. Right? I don't need an F4, so I'm not going to change it. And if I wanted just for completeness, do this, it could be A plus this times the sine of that theta. Oh, I need to add in this right here. Okay. All right. So, like I said, I didn't need to do that one. But because I only really need the open leg right here. So you'll see what I'm doing here in a second. I need to change this so that we go down to that angle and change this so we come down to this angle, and I think it'll be correct. Let me try it out. I'm taking a chance because I haven't tried this one before. We're going to add in a series where we go from here to here, boom, and from here to here, and then add in a series where we go from here to here and from here to here. And that looks like it's correct. And we don't need, by the way, we could click on these individual series labels right here. We don't need those in there, but we can keep the others in place. And you can see that that's going to be the path. So we have now made an Excel 360-degree coupler curve utility. And if we want to try it out, we might want to consider putting in some known coupler curves. Let's see, I can get rid of that guy too. Some known coupler curves for things that for a particular problem, and change the thing around. So for our 4-bar mechanism. So here's 360 degrees, and try it out. See what happens. Thank you.